Unimaginable devastation. So many large and destructive landslides occurred that there were simply too many to count. Roads, homes, and bridges were swept away, buried, or inundated by these events, occurring alongside some of the worst flooding the island of Sumatra in Indonesia has ever seen. You can even see much of this flooding from satellite. As for the aforementioned landslides, in one particular 5-square-mile area north of the Bernitelon volcano, I geolocated a whopping 285 landslides having occurred here in a 48-hour time span, with at least 20 of these surpassing the 1-acre mark. Every local seems to know someone who has been impacted by this natural disaster, with all of this being caused by something surprisingly uncommon in Sumatra, a cyclone. And this cyclone remained on land for nearly 24 hours above Sumatra between November 25th and 26th, a full week ago. Yet, if you live in the United States, all that much of the news media has done to describe these events in an international news program is briefly mention it for 15 to 20 seconds, call it severe flooding, and then move on without providing any additional context. They, in my opinion, have done a horrendous job of discussing exactly what occurred here and why it happened, seemingly not providing any additional context. This is why I, as a geology channel, am as a one-off event making a video which primarily discusses the weather, aka meteorology, to fill this coverage gap. After all, I could best describe the extent of devastation that Cyclone Sanar caused by simply calling it Southeast Asia's Hurricane Helene. In Indonesia alone, nearly 50,000 structures were damaged, occurring alongside more than 800 fatalities and thousands of other injuries, marking what has already become the nation's costliest cyclone on record. To start off, despite being a tropical nation with fairly average high temperatures and abundant rainfall, Indonesia as a whole, and more specifically Sumatra, doesn't tend to be impacted by cyclones. Almost all cyclones that form here begin to the west of Sumatra, going northwest if north of the equator, or south to southwest if south of the equator. In fact, during the last 50 years, a cyclone has only made landfall on Sumatra one other time, during Cyclone Vamay in 2001. So, while yes, Sumatra is essentially one giant rainforest that averages 350 centimeters or 137.8 inches of rain a year, this occurs across many small distinct storms that strike an average of 3 to 4 times a week. In other words, larger, stronger storms that can hold far more abundant moisture are rare, and communities here have largely not experienced such before. So, when Cyclone Sanar made landfall and dumped more than 30 centimeters, in some spots more than 50 centimeters of rain in a 24-hour time span, the plants and vegetation were unable to accommodate it all. Any form of drainage or river flooded, and rain-saturated soil became so heavy that it began to slip, especially on areas with steeper, more rugged topography, forming many thousands, perhaps tens of thousands of separate mudslides. For reference, mudslides are a subvariety of landslides, albeit the most common type of landslide that involves abundant mud from soil saturated with water. Yet, the exact origin and nature of the cyclone was completely unprecedented, forming in the narrow body of water between part of Malaysia and Sumatra known as the Strait of Malacca, marking the first time a cyclone has ever formed there on record. And then, instead of dissipating and heading west or northwest, the storm did something we've never seen a regional cyclone do. It unexpectedly turned eastwards and continued heading in that direction. For all intents and purposes in the realm of local meteorology, that is essentially illegal, and yet it happened anyways. As a result, it sort of just hovered over Sumatra for more than 24 hours, more than doubling the length of time the area experienced heavy rainfall. Some people are incorrectly claiming that deforestation caused this disaster to become far more severe, but this is simply not the case. The worst hit areas were pristine, untouched rainforest on rugged higher mountains, although if these trees hadn't hypothetically been there, the outcome would have likely been even worse. It is fairly obvious that climate change played a strong component in this disaster, allowing a storm to form in an area it normally wouldn't, especially because higher temperatures allow storms to hold more moisture and thus cause more severe rainfall events. So, for those of you who might be blaming the Indonesian government, you are honestly blaming the wrong governments for contributing to this disaster. Regardless, this disaster in some areas will likely take a long time to recover from.